Reducing equations down to quadratics, because we know how to solve quadratics. When we find particular patterns in equations, we can use the idea behind quadratics. So this is a common sort of one where we've got a polynomial equation, but the powers going down by that even amount. In this case, 4, then 2, then 0. So they're a nice even pattern. I can turn that into a quadratic. I could have done it if the powers were, let's think of another way, if it went 10, then 5, then 0. I mean, it still could be turned into a quadratic. The way of thinking about it is the pronumeral is not x. We think of the pronumeral as x squared. I mean, sometimes people like to actually substitute a different one in, so I'll call mine m. So m squared is x to the 4. The quadratic equation becomes m squared minus 4m minus 12. So the idea is still the same. What multiplies together to give, what adds together to give. And we end up with 6 and negative 2. But of course, m was some pronumeral I introduced. That means x squared is 6 or negative 2. Well, got to interpret our answer now. X squared equals 6, that's certainly possible. X squared equals negative 2, well, not in the real world. No real solutions. So x is just plus or minus root 6 for that particular equation. Doesn't have to be polynomials, however. We could have an exponential equation. When we get exponential equations like this, where you'll notice that the base of one is the square of the base of the other. Well, again, we can use quadratics to solve this type of exponential. Oh, the other thing you'll notice, I've put my 3 to the power of x in parentheses. I always write my exponential equations like that. But a lot of people use the dot multiplication. What people think it says is 9 to the power of x minus 4.3 to the power of x plus 3. And people get confused and go, 4.3 to the power of x? Oh, crazy. But just watch out for that. Use common sense. They're not going to ask 9 to the power of x minus 4.3 to the power of x. All right, I'll let m equal 3 to the power of x. And just in case you don't believe me, m squared is 9 to the x. But there's my little proof that you don't have to write that whole thing down before someone asks me. But I'm just proving that. You can play around with the index laws and you can prove, yes indeed, m squared is 9 to the power of x. Sub it in, there's our quadratic. So we end up with m is 3 or m is 1, but that's not what we want. We want x. 3 to the power of x is 3 or 3 to the power of x is 1. All righty. There's a handful to try.